I have already run this cell in order to make sure that NumPy is available. And now we're going to begin to explore this array method in NumPy. And we always proceed that with the np dot nomenclature so that we make sure that we're accessing this specific function directly from the NumPy library. We're going to create a one-dimensional Python list called PyList2. Let's do that. And there's how it looks just coming straight out of Python. What happens when we pass that PyList2 into this npArray function? Well, it converts it to a NumPy array, and it changes the output so that we can tell the difference between a regular Python list and a NumPy data structure. We can do the same thing with multidimensional arrays. So here we have a list of tuples. This is a Python list, and inside that list we have two Python tuples. What happens if we convert this to a NumPy array? So let's look at the output there. So a NumPy array stacks these in a way that it has 2 rows and 4 columns. And that's really a useful way to think about arrays in NumPy. So now that we have these 2 NumPy arrays, there's npArray 2 and npArray 3, we can explore both of the dimension and the shape. What's the difference between dimension and shape? Let's look at these and see. Here's npArray 2. This is that one-dimension array. It tells us it's just one dimension. What's the shape then? Well, it's a one-dimensional array with 8 members. Now, it's up here a little ways, but we can still see it, the output from when we created it before. So it's simply telling us that there's eight members. So the dimensions is it's a one-dimension array, and here it's telling us the shape, well, there is 8 members in this one dimension. What about npArray 3? How is that different? Here's the output from that. Let's check the dimensions. Can you guess what they are? Yeah, there's 2 dimensions. So there's a row dimension and there's a column dimension. Now, what about the shape? Can you guess what the shape is going to be? Yes, it's 2 rows and 4 columns. And that's a very useful way to think about these NumPy arrays. Now in NumPy there is a way to generate these generic arrays. And there are 3 of them to look at. There are zeros, and there are empties, and there are ones. All right, so what happens if we actually create a 0 array here? Can you guess? Yeah, it's going to create this one-dimensional array that is all zeros. Can we create a multi-dimensional array of all zeros? Well, sure. We just use np zeros, and then we say we want 3 rows with 6 columns. And let's see what that outputs. Okay, 3 rows and 6 columns. We've inserted a tuple in here inside of this zeros function. What happens if we change this and make it into a list instead of a tuple? Let's do that. There's a list instead of a tuple. Notice the difference. Hey, there's no difference. So we can use a list in here or a tuple, whatever we like, but we do have to put it inside some sort of a native Python structural framework. So we've looked at zeros. What do we get when we run this empty? Now you might think that we get zeros, and oftentimes we will, but if there's anything left in memory, any ghosts or garbage left in memory, we're going to get these random items when we create an empty. So the best way for me to think about this is as right to left under sort of a child and parent structure. So I know that these are 3 columns, which are children of these 2 rows. Okay, so here's child 1, child 2, child 3. These are the columns which are children of these 2 parent rows. So these 2 parent rows are also children of these 2 parent rows. So here's parent row 1, parent row 2, right? And this then would be child row 1 and child row 2. And this then would be child column 1, child column 2, and child column 3. what do you think NP1s is going to produce? Now remember, we're going to end up with 2 columns inside 4 parent rows, and then we're going to create 3 rows of that, if that makes sense. Let's see it.